and this is a talk about scripts. You can also check out this talk from GitHub, and I have an example at the end that I'll need some volunteers to help run. So if you have stuff handy, 1 or 2, 3 courses. Okay, so JavaScript, JSON, etc., etc. So you might have, if you've seen Node, or you might have heard about callbacks, right? People who have done this? Very good. Now, so there's some problems with this. So here we're just going to load a JSON file, and then we're going to parse it, and then we're going to output value from each row. Seems simple enough, except that file happens to be 360 megabytes. Oh, didn't work. However, so the problem there is we tried to load everything into memory and then parse everything all at once. And this incidentally is all of the metadata, package JSONs, and readmes, all of the like 20-something thousand modules on NPM. So that's too big for JSON commands. So, but with this other thing, module called JSON string, which is a streaming parser. So we'll load the file bit by bit, pipe it through the parser, and then just select the part that we require. Apply this path to it, and then we just run back. In this case, of course, it works. Also, it starts outputting data immediately, which is good as well because then we can start working on the output. You'll also see that it's much simpler code. There's much less nesting here and there. It's just one thing, go straight to the next thing, go straight to the next thing. So if you're worried about callback help, it's not really a problem with strings. Another example. Let's say we want to load a file, and then we want to compress it, and then we want to write the file or something again. Then that is this isn't too bad, but it's beginning to get a bit hairy. Where one thing's hitting up the other, doesn't really work that well. Doesn't look that great. Let's do that. No. Here we go. Or we can do it like this. Much more straightforward. And very fast as well. Now the difference here as well is because this is a live demo, I didn't download this off the internet. But if you were doing in real life, you could quite possibly be requesting this JSON with an HTTP request, and say if it's particularly large, like it takes 10 seconds to gzip this 300 megabyte JSON I just showed you. So if you had to download the whole thing, then compress the whole thing, then write the whole thing to disk. Writing to disk would be really fast, but downloading it and zipping it would be quite time consuming. Now, in real life, probably the network is what we mean. Reading from a disk, it it'll be the CPU actually. But if you're streaming it all, because you have to wait for the network to give you stuff, you can progress it as you go, and then by the time you finish downloading it, you pretty much finished zipping it as well. So streams are not only more convenient to read, but they're also faster. And they're faster in an interesting way as well. You don't really, they're faster because of architecture. They're not faster because they are like, because they work harder, or because they can do some trick and make the process faster. They're actually slightly slower, just slightly. But they can start, with the stream, you can start working on it before you have everything. So they don't wait to do work, they can do it immediately. So instead of, if you load the whole file, then you have to wait for that whole thing to arrive. Then you have to crack it. Then you have to process the whole thing in one go, and then you have to do the next stage. But in the stream, these three phases can all overlap into one thing, and the whole thing gets through faster. Because architecturally it's better. However, the problem is everyone's used to doing things like you read a file and then you pass it and then you iterate with the array method, etc. But streams are just like arrays, but arrays in time rather than in space. So here's a simple example. So we're going to do an HTTP request to get some data. Then basically this is just a comma separated vector, and we'll split it into lines with a regular expression, and then we'll split each line by commas and then turn it into an array of numbers. Then we'll pipe it to a through stream, which is just a stream that does, it just passes every piece of data to a function, and the function can emit data, can send data out, but in this case it's just consuming data and writing it to console log. Run it. As you can see, just like iterating over array, but we're not waiting for the whole thing. We're not loading the whole thing before we start. So streams are real time. Here's another slightly more complicated example. And this time we'll load the JSON data again, and then we'll get all of the readmes, and then we'll split the readmes into words, and then we'll count all the words. And then at the end we'll output the counts. This will take a little more. Really fast. Much faster than expected. yeah, so that's a little bit more complicated, and it's basically just like another function you might do on an array. This is like reduce, but we don't wait for the whole array to load until you want. Now, because everything we do in Node.js is asynchronous, sometimes we need to do asynchronous things while we're doing string. So here, in this case, we'll just create a string, we'll pipe to it, we'll give it a file name, and it will return, we'll give it the file name, and we'll write to that file name, we'll create a directory with that name, and then it will write the file with the same name. It doesn't really make sense to put it inside the directory. Okay, and once an input. Okay, so we're gonna pipe a file to a thing, and we're gonna be like, here's a file, and we're gonna start a file path with the directory, and then we'll create the directory before putting the file in the back. Sorry, that's it. But creating the directory is an asynchronous operation, so hopefully some metrics. So nothing's there. It should look like this. So this is a thing that you need to know with classical strings, which is from Node 0.8. Before, you don't have to worry about this with 0.10. But if you use a reliable string like string and that you can tell it to pause, and then no more data will come up, and then it will wait until the call goes 0. So let's try this again. Here we go. Okay. This is one of the great things about it. This is a proxy, which is a proxy TCP to another place. Now this, and any other language, wouldn't be 3 lines of code. That would be, I don't know, you have to run a special program to do that or something like that. It would be hard, but this, very, very easy. So let's run that. And then I'll just create something a bit too close. And then I'll just make a request to it. So that started a static server on port 800, port 8000, and this is going to proxy 3000 to 8000. So there's 3000, which is the proxy, and then get that message from the server.